We're going to look at some more problems for chapter 1.1. This time we're going to attempt to use a variable to solve this problem. We'll also use looking for patterns and making lists to help us answer this question here. But again, here are the clues you would kind of give us to when we want to use a variable. And so this is a very classic problem. Find the sum of the first 10 numbers, 100, 500. In general, find the sum of the first n numbers. Like, what's the sum if you add these numbers together? And so to add this again, this is kind of a tricky, it's not always obvious why we would do this. But again, it's a classic problem in mathematics. And so one way to think about this is, well, let's try the 10 first, right? 1 plus 2 all the way to 10. You can just add that up in your head, calculate it, and you get 55. But a pattern to solve that, right? 1 plus 2 plus 3 all the way to some number is to add the number twice together. So for example, 1 plus 2 all the way to 10, and then add with each of those numbers 10 plus 9 plus 8 going the other way. And if you look carefully, that always sums up. That will sum up, in this case, to 11. And so the pattern exists is that when you add this with itself twice, right, you get 11. And how many 11s are there? There are 3, 4, 5, 6, 7. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 times 11, but we divide by 2 because we added it twice. And so the sum of that is 55. So using that idea, we can then find a pattern that we could do that for any size number of n. And what turns out is then what you're doing is it's going to be n times n plus 1, right? If 10 times 11. So if it's just n, it's n times n plus 1 and divided by 2 because we added those numbers together twice. And so then this is the formula or the equation that you would end up using. And so then you can find the sum of the first 100 numbers and 500 numbers. So again, if you don't get this right away, it's understandable, but it's really trying to think out of the box, being open to trying things. And then now you learn from this one that maybe this technique would work on a different type of problem. Let's continue with some examples. These may seem simple, but the idea is describe different ways to add these dots. And so I want you to think about that. Add them up, how many are there? And what turns out, there are 16 dots there if you count them up. One way is just to count them. And then I wrote some other ways down here. These are just my ways of thinking, but there could be other ways of how you see to count the dots. You can see 5 and 5 plus 3 and 3. There's 5, 5, and then 3 and 3. So there's your 6. The way I saw it was, the way I was thinking about it was you have 4 corners, 1, 2, 3, 4. There's the 4. And then you have, there are then left over here, right? There were the 3 here. And then so that's 4 times 3 plus the 4. So that's another way. Or some people then see also, let me erase that, other people see you have 4, 4, 4, and 4. There's your 16. And so you come up with many ways. The important thing is that there are many ways to solve problems like this and how you see it. The answer is 16, but most important is the way we do it. Now you're going to extend that problem here. And what happens if we want to write an expression, algebraic expression that shows you how many dots are there for how many dots are there, right? For how many dots on the side. And so in this case here, like on this case, we knew there was 5 dots here. When there was 5, there were 16 altogether dots when there's 5 on the side. And so what formula would we come up with that? And so as I look carefully here, what you see is, if you look carefully on that, we had the 16 there for that first example. And so what would it look like? What are we developing here? is that another way is that I see it, if there was 5 here, I saw this is the way kind of I saw it, is there's your 4 times 5, and then you subtract the 4, meaning that there are 5 on each side, right? So it's 4 times how many on each side, and then you subtract the 4 are the 4 corners, because you're double counting. So that's one way to kind of come up with a formula. And so when you see that as the formula 4n minus 4, you get 4 times 5 is 20. Let's do that again. 4 times 5 times 20 minus 4. And so then you end up with your 16. So that's one way to kind of see that equation there. There are other ways to see, so that's just one equation that would work out. Now, extending that equation to this here, how many dots are on the side if you have 84 total dots? So one way was just, again, the formula is 4n minus 4, and you want to try that out for different sizes there. And then you just set that equal to 84, then we use some simple algebra, and so then we find out there would be 22 dots on the side there. And so for the last problem here, looking at this learn check, you want to try this out. But again, I used a combination of equations, variables, and guessing and testing to try to get us this answer here. And notice here, pigs have 4 legs, chickens have 2 legs. Pigs plus chickens has to be 24, because those are how many heads there are, right? So 4 pigs plus 2, 4 times number of pigs, 4 legs times the number of pigs, plus 2 legs times the number of chickens equals 80, because that's how many feet there are. Oh, I should say legs. Those should be feet, right? And so, but then that can be put into an equation like this. And so we can just guess and test, put some numbers in there and see what we get. 10 pigs, 14 chickens would give you 24 total, but it would give you 68 feet. So it's too low. Let's increase the number of pigs. Since pigs have 4 feet, we get 24 total pigs and chickens, but then we get a total of 76. It's still too low. We're trying to get to 80 here. So a guess that we would put in here is to take a guess and say, you know, let me try 60. If we had 16 pigs, we would have 8 chickens. And so I know that is equal to 24 when you add that. 16 times 4 is 64. And then 2 times 8 is 16. So that equals 80 feet, and so that's perfect, and so that's our answer there. How many pigs and chickens? We would have 16 and 8. For those of you who like algebra and see this as a system of equations right here, this is a system. You can solve that algebraically if you're feeling good with your algebra skills. And so this is a systems of equations here. And I have the solution here already solved. And so you can see I used a substitution method. You can pause and take a look at that.